Hi, welcome to part one of milk and milk products. And here are the objectives that you're going to go through. First of all, you're going to look at the composition and nutritional contribution of milk. And then we're going to explain the various ways and rationale for processing milk. Then you're going to identify a range of dairy products. Then discuss the chemical and physical effects of milk products, such as enzyme, acid, and salts, and heat, and how they have an effect on milk products. Then we're also going to explain the formation of milk and cream forms. Describing the composition and nutritional contribution of milk, we are going to draw a chart. And as you can see in this chart, you realize that we have proteins, which are about 3.5%. We have fats, which are about 3.3%. Then we have water. Water makes the greatest component of milk, which is 88%. And then we have carbohydrates, which are about 5%. So you have to take note that different breeds of animals, species, and even the process of milking itself has an effect on the composition of milk. And when you're talking about the lipids quality of milk, you realize that some specific types of animals, such as the Jersey and the Guernsey, have an excess of milk by about 5%. Now, if you want a quick recap on what lipids are. So lipids are basically the fat components of, in this case, the fat components of milk. And basically, there are a variety of organic compounds that actually occur naturally in nature, and they're classified based on their solubility properties. So normally, the lipids have a hydrophobic tail and a phosphate or group, which is actually hydrophilic. So we would say that this property of having both the hydrophobic and the hydrophilic end makes milk a perfect emulsifier. Now, you want to know what an emulsifier is. So basically, an emulsifier is something that will be able to blend both water and oil, ingredients or components, and to make them have a sort of harmony. So if you use the FDA approved definition of a emulsifier, is like something that will aid both the immiscible and the miscible part of the component to sort of blend water and oil together. So as we go on, we realize that milk also, still on the components of milk, we realize that we still have milk separating, having the aqueous form and the creamy form. Now, still on lipids, well, as we understand what lipids are further, we get to understand that triglycerides in milk contain the fatty acids that are actually deposited in tiny fat globules. As you can see here, we have fat globules. If we take this portion out here, you realize that we have a lipid portion, we have a fat globule, and we have a lipoproteins. So if you take this further, the lipid portion further, you will get that we have the fatty acid portion and the phosphoric portion. So you have phospholipids. Generally, we have glycerol, we have fat globules. So these whole chain of these makes the lipid, the sort of a lipoprotein. So each is surrounded by a fat globule and a membrane of phospholipid protein. So we also realize that milk, as we said, it also have carbohydrates, which make about 5%. So the carbohydrate, let's say that for a cup of milk, you have around 11 to 12 grams of carbohydrates. And when at cool temperatures, it tend to easily precipitate out. So during processing of dried milk solids, and we have crystals of alpha lactose, which actually form when you dry milk solids. Now, this process also makes powdered milk to clump together. And the level of lactose is sufficient to give milk a sweetness and browning of heated milk. So we realize that this alpha lactose is actually important in milk processing, because in milk, because it gives it a sweet taste. So you have to realize that lactose is a carbohydrate. A carbohydrate of milk is called lactose. And in this form, we have the alpha lactose, which when you process those milk solids that you normally see, that are actually very highly hygroscopic, is a component of milk. Now, when you realize that proteins make 3.5% of milk, and we have two major proteins, the casein and the whey. Now, the casein is the insoluble and actually precipitate faster to form the soft card, leaving the whey, which is actually a watery mixture. So the whey protein and the casein, which is we have the alpha and the beta, and the K casein, and the other form, which is gamma casein, which is not actually very abundant. Which are generally, the caseins are formed in aggregates that we call micelles. Now, we also have flavor components in milk. We have the ketones, the aldehydes, and the acids. We also have the protein micronutrients, which are basically enzymes such as alkaline phosphatase, xanthine oxidase, proteases, and lipases. So this makes the whole summary of what milk, the composition of milk. And we say the composition of milk is water, which makes the highest percentage, the carbohydrate, the proteins, and fats. We've also said the carbohydrate is basically the lactose, and the lactose makes about, it's actually what gives milk the sweet flavor. And when you have dried solid milk, what we have, which is actually very hygroscopic, or it causes powdered milk to lump, is actually the alpha lactose. And you also realize that we have the proteins, and the protein, you say we have the casein, and we have the whey. The casein is now the insoluble, the one that precipitates out easily to form a soft card. And we have the whey, which is actually a watery mixture. Then we have flavors. Now, flavonoids, we have ketones and aldehydes in milk, and also have proteins and macronutrients, which have enzymes, and they have vitamin D. Normally nowadays, to make fortification of milk, we add vitamin D, and we also add minerals such as vitamin C and iron. That makes the simple answer of what are the components of milk and what are their contribution to it. The components of milk, you realize that hey, if you find these videos useful, remember to subscribe, like, and share.